Hello everyone, welcome to another episode of Mind Map. Today's topic of discussion is theories on origin and formation of continents. First of all, we will discuss about the introduction of the topic. Then we will discuss about continental drift theory, convection current theory, theory of seafloor spreading, and lastly, plate tectonics theory. First of all, moving on to the introduction of the topic. The Earth, a dynamic and ever-evolving planet, has fascinated scientists and geologists for centuries. One of the core areas of study in Earth sciences is the origin and formation of continents. This field has witnessed the emergence of various theories over time, each contributing to our understanding of the Earth's geological processes. These theories, rooted in meticulous observation and scientific inquiry, offer insights into the movements and changes of the Earth's surface. From the early 20th century to the present, the evolution of these theories reflects a journey of discovery and understanding. Now let's discuss about continental drift theory. Alfred Wegener first proposed the continental drift theory in 1912, building upon the earlier hypothesis by Abraham Ortelius from 1596. This theory posits that about 250 million years ago, there was only one supercontinent called Pangaea, surrounded by a vast ocean known as Panthalassa. About 200 million years ago, Pangaea broke into two parts known as Laurasia and Gondwana land. According to Wegener, continents drifted towards the equator and westwards, influenced by gravitational forces, centrifugal force due to the Earth's rotation, and tidal currents. This theory is supported by the jigsaw-like fit of continental coastlines, notably between South America and Africa, and similarities in geological formations and fossil records across these continents. Now let's discuss about convection current theory. Arthur Holmes introduced the convectional current theory in the 1929. The theory posits that radioactive substances deep within the Earth's mantle, that is between 100 and 2900 km below the surface, generate significant heat, leading to the formation of convection currents. These convection currents in the mantle are crucial in driving the movement of the Earth's lithospheric plates. The theory describes how divergent convective currents pull apart crustal blocks, forming oceanic features, while convergent currents cause subsidence that leads to mountain formation and other geological structures. The theory explains the formation of major geographical features like the mid-Atlantic ridges and East Africa's lake systems, demonstrating the impact of mantle convection currents. Now let's have a look at theory of seafloor spreading. This theory, proposed by Harry H. Hess in 1960, revolutionized our understanding of oceanic crust formation and continental movement. The theory describes how magma rises at mid-ocean ridges as the crust pulls apart in opposite directions, cools upon contact with seawater, and forms new oceanic crust. Mid-ocean ridges are central to this theory, serving as sites for new crust formation through volcanic activity, with the crust gradually moving away from the ridge. Old oceanic crust is recycled back into the mantle at subduction zones, where it is destroyed and reforged, maintaining a balance in the Earth's crust. The East Pacific rise is highlighted as a region where seafloor spreading occurs most rapidly, involving several tectonic plates like the Pacific, Cocos, Nazca, North American and Antarctic plates. Evidence supporting the theory. Magma evidence. Rock pillows formed from rapidly cooling molten material along mid-ocean ridges. Drilling samples. Core samples showing younger rocks at ridge centers and older rocks further away. Magnetic stripes. Patterns of magnetization in ocean floor rocks that record changes in Earth's magnetic field. And subduction and deep ocean trenches, ocean floor descending back into the mantle at deep ocean trenches. The theory explains variations in sea level and the carbon cycle, influenced by the rate of seafloor spreading and associated volcanic activity. Now lastly, let's discuss about plate tectonic theory. Plate tectonics is a central theory in geology explaining the movement of Earth's lithospheric plates which constitute the outer shell of the Earth. The Earth's lithosphere is segmented into several large and smaller plates comprising the crust and the upper part of the mantle. These plates float on the semi-fluid asthenosphere beneath them. The movement of these plates is driven by convection currents in the Earth's mantle caused by the heat from the Earth's interior. Plate boundaries. Geological activity primarily occurs at the boundaries of these plates, which are of three types. Divergent boundaries, where plates move apart, leading to mid-ocean ridges and drift valleys. Convergent boundaries, where plates move towards each other, causing subduction zones, mountain ranges, and volcanic arcs. Transform boundaries, where plates slide horizontally past each other, leading to earthquakes. The theory is based on assumptions like the division of the lithosphere into plates, the extension of continental plates over oceanic lithosphere, and the influence of convection currents on plate movement. The theory is supported by evidence such as the fit of continents, distribution of earthquakes and volcanoes along plate boundaries, age of oceanic crust, and magnetic stripping on the ocean floor. Plate tectonics explain the formation of major geological features like mountains, oceanic ridges, trenches, and the occurrence of earthquakes and volcanic activities. Major and minor plates. The Earth's lithosphere is composed of major plates like the Antarctic, North American, South American, Pacific, India, Australia, New Zealand, African, Eurasian plates, and several minor plates. Plate tectonics is key in explaining the distribution and mechanisms of earthquakes and volcanic activities, which predominantly occur along plate boundaries. This theory underpins our understanding of the Earth as a dynamic planet with constantly moving plates, shaping the geography and geology of the planet over millions of years. Now it's time for the practice questions. First of all, prelims question. Consider the following statements. 1. Alfred Wegener's continental drift theory suggested that continents were once part of a supercontinent called Pangaea. 2. Wegener's theory was widely accepted in the scientific community when it was first proposed in 1912. Which of the statements given above are correct? Only one, only two, both one and two, or neither one nor two. And now mains question. Analyze how the plate tectonic theory has revolutionized our understanding of geological processes. So that's all for today. Stay tuned for the next episode. Thanks for watching.